We'll be talking about what can we dig from Common Criteria and FIPS 140 regarding OpenSSL, given that we are at the OpenSSL Conference. I'll roughly start with the motivation on why and how we are trying to dig things from certifications, then do a little bit of a detour to the preliminaries of like how certifications work and how our tool works for those that may not be aware. Then we have a large block on the actual results from Common Criteria and FIPS 140, and then we conclude. So what is the problem that we are looking at and why we are looking at it? Everyone likes free and open source software, at least many of us here in the conference, and OpenSSL is one of the examples of such a pieces of software. However, with FOSS, there's a couple of deficiencies. The thing is that when your software is free and open source, you have little awareness of how prevalent it is and who actually uses it. If you knew, you could use that for bragging rights as well as negotiations on funding. For example, if you are a non-profit foundation of the OpenSSL style, you have no ideas how which versions are how common out there and what's the security behavior around that. You don't know which vendors include your products because the products might be proprietary and nobody will even let you know because it's free and open source. Similarly, which products they use it in and in which they don't. And how prevalent the alternatives are. Often the alternatives are also open source, or maybe not. But you're not totally in the dark regarding all of these things. There are proxies and side channels to get some basics of the statistics regarding these things, even if you are open source and free. One of the common proxies is product component information. This takes multiple forms, one of which is dependencies, because open source software cleanly comes with the dependency list in its repository. However, this is only relevant for open source software. For proprietary software, recently coming bill of materials or software bill of materials information may come in handy and may leak that they use your software even if your software is open source and they didn't let you know because they can. A third component information that is relevant is legal license notices, because if your software is GPL or similar, whoever uses it might legally need to acknowledge that they are using your software, sometimes even with a particular version. But harvesting this data is kind of complicated and usually not automatic. Another completely different proxy to get this sort of awareness on your open source software is public data artifacts. The particular graph on the screen is taking the whole TLS scan of the internet and doing statistical analysis on the keys generated for the certificates and trying to devise which library the key was actually generated by. And then you will see that this is OpenSSL and this is all of the other libraries. If you got more interested into this, 3 authors of the paper are actually in the room, one over there, and I don't think the third one is in the actual one, but elsewhere. The third proxy that we can use is certification documents, and which is how I'm coming back to what we are going to be talking about, because in public certification documents about proprietary and internal products, you find things like, oh, use is OpenSSL, usually even with a particular version, with more details on how OpenSSL is used. So in the big picture, trying to get awareness, or maybe even a little bit of control of where your software is used, of the 3 proxies, we are going to be focusing on what can you mine from public certification documents. And we'll be talking about OpenSSL because we had to choose a use case, and this is a fitting one for the conference. For the preliminaries, security certifications. The general idea is we want to have secure hardware and software more secure by putting the thing to an independent audit by a company. Whether this is actually the case or not is a completely different topic that I won't be coming into in here, but this is the general idea of the certifications. There's many of them, and it generally works in this way. You, as a vendor, create a product with all sorts of specification and documentation. You give that to the certification lab, who does the assessment and the evaluation, create the certification report, and they hand it to the certification authority, usually a national one, maybe a global one, who issues a certificate, selects a subset of the documentation, usually the specification and the certification reports, and publishes those. So in the end, online, there's a set of certification documents that's public, and that's a subset of all the documentation. The thing is that this includes information that you would otherwise only learn by signing an NDA with the vendor, because it's internal information about proprietary products that are certified. So you can use it as a side channel. During the talk, we'll be talking about two certification schemes in particular. It will be Common Criteria and FIPS 140. Both are global, although FIPS 140 was originally devised as a North American scheme. And the core difference is that Common Criteria is for products, while FIPS 140 is for cryptographic modules, so more crypto-focused things and smaller and not necessarily finalized in a product state. So OpenSSL itself has a FIPS certificate, but it doesn't have a Common Criteria certificate because OpenSSL is just a component. To analyze the ecosystem, we used the SecCerts tool, which has the idea to allow you to explore the ecosystem of CC and FIPS by taking the open source software that we wrote, the SecCerts project, taking the open certification data at the websites of the certification agencies, CC and FIPS 140, crunching those and providing those publicly to you on a public website. It's an academic project started at Masaryk University and is a long-term cooperation with Red Hat, now co-funded even within an European Union project. The core idea of SecCerts is we take the public certification documents, we crunch them into text that is easily processable, we crunch all sorts of heuristics and analytics on the text, even cross-correlating with external databases such as CPEs, CVEs, and similar. And we have an augmented database of certification metadata that we basically publish back online for people to search through. And what we learned from the database regarding OpenSSL, my co-speaker will tell you now.
Well, let's take a look to the results of our analysis. First of all, I'm going to speak about common criteria. First question Martin already asked was how prevalent OpenSSL is in the certified products. We can see that in OpenSSL, in the certificates, the OpenSSL is mentioned like 7,555 times. And this is like an example of the mentions, how it looks. Yeah, sometimes it's saying that OpenSSL is used to implement TLS. Sometimes it's just saying that OpenSSL is just there in some version. And sometimes it can happen that it's just saying that OpenSSL is Boring SSL is a fork of OpenSSL. So it's actually not saying it's using OpenSSL, but it's quite rare appearance in there. Here we can see the graph of the mentions, like how many times the OpenSSL is mentioned in a certificate. And here we see that mostly the OpenSSL is mentioned just a few times, like 1 to 7 times in a certificate. So not that much. Overall, we found out that over 1,000 certificates are mentioning the OpenSSL, which corresponds with 17% of the all certificates we have. And in the data, or more or less in this chart, we can see that during the last 10 years, the 23% of all certificates are mentioning OpenSSL. So it's showing some kind of a trend of the growing popularity of the OpenSSL library. Then we asked what kind of products are certified and using OpenSSL. And all the common criteria certificates can be split into those categories. And as you can see, those 3 categories, which is network-related systems, operating systems, and detection systems, are mentioning OpenSSL in more than 35% of certificates, which is quite a significant amount. Also, we need to know, we wanted to know how many companies are using the OpenSSL, which is saying to us that 313 distinct vendors are mentioning OpenSSL in their certificates, which is over a quarter of the market. And here we can see like top 20 of the companies mentioning OpenSSL in their certificates, which can be interesting for the OpenSSL project because they can be potential customers, theoretically. If we take a quite deeper look into the data about the vendors, we can see some trends. Yeah, like for example, the oldest company who is using the OpenSSL for the longest time. Yeah, the oldest vendor, and it's Red Hat and IBM. Those two companies are using OpenSSL since, or mentioning the OpenSSL since 2004 or 2007 for in IBM case, and they are using it until now. Yeah, so those are the oldest manufacturers or vendors using the OpenSSL, but they are not the largest. The largest ones are Juniper, Ryok, and Xerox, where we can see again some kind of a trend, because here in 2016 and 17, since 2006 to 2016, the Xerox was like a dominant user or mentioner of the OpenSSL. But in this year, something switched, and from here until now, the Ryok is taking a lead in mentioning the OpenSSL. And there's one more trend we found out, and this is that McAfee stopped mentioning the OpenSSL in 2014. So since 2014, they probably started using different library, or maybe they use different approach, or stopped certifying their products. We don't know. Yeah, and last but not least question was, which alternatives are used in certified products? And we have two categories. One of them is the forks of the OpenSSL, where by far is leading the boring SSL library, which is mentioned like over 8 times, or it's mentioned in over 80 certificates probably right now, because those data are from Monday, it's changing every day. And then we have a second category, which is the competitors of the OpenSSL, yeah, where we can see the leader is NSS with over 70 certificates, and mostly used by RH and IBM. Same here with libgcrypt, mostly used by RH, SUSE, and Oracle. There are chart of the forks and alternatives for the OpenSSL, and still we can see that OpenSSL is still the strongest player in the field. But here, I can switch to the next slide. Here we can see that the alternatives like NSS and boring SSL are getting significant part of the market, of the certificates. And also we can see that libgcrypt was mentioned since almost the beginning. Yeah? So it's used since 2006, and it's used until now. But here, last 5 years, libgcrypt and boring SSL and NSS are getting more and more popular. Well, and now we can take a look on the same questions in the FIPS certifications. So again, how prevalent is OpenSSL in the FIPS certificates? And now we see that it's mentioned over 9,000 times. And again, the graph is quite similar. Yeah, we see that mostly in certificate it's mentioned 1 to 10 times. Yeah, something in this range. Yeah, so certificates not usually mentioning the OpenSSL more than 10 times. So it's not pretty common. We found out that certificates that are, there's 819 distinct certificates mentioning the OpenSSL, which is around 16% of the market, which is quite similar amount as in case of the Common Criteria. And again, as in case of Common Criteria, we can see that during the last 7 years, 10 years, something like this, almost quarter of all new certificates has been mentioning OpenSSL. So again, there's a growing popularity of the OpenSSL through the last few years. What kind of certified products? We are talking about the categories. In FIPS, it's quite easier because we can split all the certificates just through the 3 categories, which is hardware, firmware, and software, and some hybrids and combinations of that. But most of them are just certifying the software and hardware stuff. Yeah, so this is the part for the rest, and it's so little number we can even talk about it. Yeah, next question was the vendors who are using the certified products, and we know that 291 vendors distinct vendors are using the certificates, which is over the quarter of the market. And here we have, again, the plot of the first or top 20 mentioners of the OpenSSL. And again, same as in Common Criteria, those could be potential customers of the OpenSSL corporation. With the plot of the all companies, we can watch some trends. Yeah, and the oldest vendor mentioning OpenSSL is Aruba. Yeah, so we can see that again, it's using OpenSSL in the certificates in 2004, and it's using it until now. Yeah, like 2025, it didn't used yet. It can change anytime. And let's switch to the largest user of the OpenSSL, like a vendor who is using the OpenSSL the most, and it's definitely Juniper, who started to use OpenSSL in 2012, and it's using it until now. And here we can see that since 2016, the usage is quite consistent. Like every year, it's certifying slightly the same amount of certificates using OpenSSL. And the last question was about the alternatives for the FIPS. In the FIPS certificates, alternatives for the OpenSSL library. And again, it's quite similar. Boring SSL is the leading the category of the forks of the OpenSSL with 57 certificates. And in like a competition of the OpenSSL, the most used library is NSS. So again, same story as in Common Criteria. Yeah, those two libraries are leading each category. And if you take a look on the forks and the alternatives in this chart, we again can see some trends, and it is that the libgcrypt and NSS is used since the beginning, until now. And here the boring SSL is gaining the popularity, and it's used more and more, because we can see that it's getting like a significant part of the market in those last few years. Yeah, thank you. It's from my slide. It's all from my side, and I'm giving the word to Martin.
You've seen quite some numbers and graphs at the moment. The slides will be available with the recording, so you can dive into the actual numbers and companies and stuff like that. We decided to show you the trends rather than be discussing the individual companies, but there will be ample time for questions, I believe, so if you'll be interested, we can even return to one of the slides to examine it more and ask questions regarding it. So. Concluding the graphs and the stats that you've seen, Sectors is a tool that kind of works as a unified API over Common Criteria and FIPS 140 documents for searching them, asking queries, getting the stats, to give you leads to start digging deeper into the certifications and into particular cases that you find by the surgeon, by the weird stats, because there are outliers that sometimes fall out of the searches that you get. You can use it to get unseen or non-obvious and obvious insights about OpenSSL or potentially any other product, lab, vendor, or whatever you decide. You kind of find that OpenSSL is a really significant player in the crypto market. I mean, thank you, Captain Obvious. But the thing is that now it's not just gut feeling. You have data on that. And having data is the different thing than having a gut feeling because of the bragging rights, funding opportunities, and all those things that I've mentioned at the first slide or in the introductory part. To summarize the core trends that we've seen, it seems that in the last 10 years, roughly every fourth certificate mentions OpenSSL. Overall, in the whole certification ecosystem, it seems that about every sixth certificate mentions OpenSSL, but this has grown to every fourth in the last quite some years. Similarly, about a quarter of all vendors mentioned OpenSSL in at least one of their certificates over the time, which is again a significant number. And although not everyone uses OpenSSL, quite many of all those vendors are, and it's a variety of vendors. Looking into the alternatives, NSS, Boring SSL, and libgcrypt are most common. and we could be diving into more interpretations of all this data, but it's kind of tricky. For example, for boring SSL, we could have like we could suppose that, oh, it's Google behind boring SSL, so it may be Android pulling the certification phase in OpenSSL, and we could use sectors to dive deeper, which we did roughly, but this would start to be a lot of manual analysis, and we decided to go like quantitative overview for the talk, while deeper analysis could be done in individual parts, and we'll probably select those and make those largest thesis and then potentially even an academic publication later on. Kind of surprisingly, the situation is very similar in FIPS and FIPS 140 and Common Criteria, and I'm not speaking about the general trends of OpenSSL being prevalent and many vendors using OpenSSL. I'm even speaking number-wise, because even the thing that roughly a sixth of all certificates mentions OpenSSL, and roughly a quarter of those in the past 10 years mention OpenSSL, and it's roughly a quarter of all the vendors, almost the same numbers appear in both of the certification schemes. It would be interesting to see other certification schemes, though for the moment Sectors only processes the two, which are kind of the global players, so including other certifications might be a thing for the future. However, the data is not 100% precise, so let's look at some of the limitations and biases of the results that we've seen. There are dataset deficiencies. Sometimes the PDFs of the certificates and the assessment reports are broken. Sometimes they are images and the OCR fails. Sometimes they are in French. And I mean, parsing French kind of messes up with the pipeline, though today with the use of LLMs, we could even leverage French certificates. There are parsing imperfections, by which I don't necessarily mean like deterministic manual parsing, but I mean the semantics gets ignored, such as Vladia mentioned at the beginning that sometimes the mention of the OpenSSL is without actually using OpenSSL, saying, oh, we use boring SSL, which is a fork of OpenSSL, because we want to mention what it's a fork of, without any particular further reference to OpenSSL. This doesn't seem to be particularly common, but this is just a very rough manual analysis of the ecosystem's dataset. Again, at this point, leveraging LLMs might be an interesting, or like either LLMs or custom ML models might be interesting to actually get the semantics out of the text on a deeper level. Then the parsing imperfections include like consolidation of metadata and heuristics from different sources, because the Common Criteria portal says you some of the structured things, then you get something out of the document headers, you parse something out of the actual text, and sometimes the information is conflicting on like, oh, who's actually the vendor? And sometimes it's like Aruba, sometimes it's like Hewlett-Packard, but then you learn that Aruba is a Hewlett-Packard company from a particular year, so it's probably the same. But consolidating these pieces of metadata is far from trivial. Again, a next step in the analysis of like trying to get more reliable things and assess how many sources the particular piece of information has to make the dataset even more precise. Lastly, you've seen, and we've been very precise in the language, that you've seen the stats of mentions of OpenSSL, not necessarily uses because of the semantic parsing that I just mentioned, and you've seen certificates that mention OpenSSL, not necessarily saying products that mention OpenSSL. Because there are certificate renewals in FIPS, so you can take a certificate and just renew it. There are product versions, so sometimes certificates are very similar to each other because it's like product X 9.0, product X 10.0, and this is kind of a single product. So maybe if we again dug deeper into this, we would find that it's not that many products using OpenSSL. The products maybe are just too common and have multiple versions, and so they explode in the number of certificates. Again, we have some informal guesses, but far from being able to say reliable stats at the moment. Lastly, and I would actually say primarily, keep in mind that the stats that we've seen is a particular niche. It's the niche of certified products. As I've mentioned at the beginning, there are multiple proxies and side channels to learn about where your free and open source software gets used. And this is just a look on the certified products, not necessarily on the general use. But again, we can now cross-correlate it with, for example, the slide on OpenSSL use in TLS key generation, and potentially correlate it with the use from of free and open source dependencies and stuff like that. If you look into the future on the potential extensions of the analysis or maybe even of the tool, you can use search for multiple things than looking into a particular product. You can go to, well, product or a component, but deeper in it. So start asking which OpenSSL versions are used. Is it mostly the most common? And you can then find when the certificate was awarded or actually submitted, what version of OpenSSL it contains, because maybe it was already an old version by the time of the submission, but maybe it was a current version at the time of the submission. It's just deprecated now. So the analysis kind of grows more complicated in that. We've tried looking into the versions, but the problem with the whole certification ecosystem is that this is from people to people historically, so it's PDFs, not machine-readable information, and the PDFs are kind of written by hand. It slightly shifts, at least in the case of FIPS, into a more structured format, but still, and it means that sometimes that the text varies quite a bit. So we use OpenSSL version and then the version number. We use version number of OpenSSL. We use OpenSSL in multiple versions, especially, and now a version number, and parsing these information out is far more complicated than it might look, because when you're mentioning the version of OpenSSL, you usually mention 3 other dependencies that you actually have in the same paragraph with, again, a string that is a version number. It's just not a version number for OpenSSL, but for a different dependency that is mentioned just before it or just after it, or maybe it's even in a table, because tables are great for humans, not necessarily so for automatic PDF-to-text scraping analytics. So interesting question. We tried diving into, but the results weren't reliable enough, so are not presented. Apart from products and components, we could be looking into labs. So if you're looking for a certificate lab to put your product to, you can start asking which lab did do smart cards recently, because I have a smart card and I want a lab that has experience with it. And everyone will tell you that they have, but only some of them actually did the smart card certification recently. You can even be starting to ask more general questions in the ecosystem of how long it takes to get a FIPS certificate awarded from the point of the submission, with the dreaded answer of a year to a year and a half at the moment, I believe. And in theory, you can be cross-correlating that with the lab to find out if some of the labs are actually faster than others, which is an information that isn't necessarily public, although is divisible from the public data, and the labs may not necessarily be particularly happy about you knowing that. Lastly, you can be doing security analytics on the products, which is a thing that SecCert originally was created for. One of the original authors was just interested, what can they learn about the products without getting an NDA signed with the company? Because without an NDA, whatever we learn about the product, you can use for research and for analytics and for interesting reports that you then publish online. And thus, that was the mention at the very beginning that we cross-correlate certification data with other databases, namely CVEs, CPEs. So in theory, you could be going into the direction of taking products, devising CPEs out of those, and then correlating the certified products with the CVEs to find out whether there are any vulnerabilities in the products. And there are many more caveats in this, because the certified versions are often different than the ones that are not certified by having different dependencies, so the CPE connection might not be reliable. But in theory, you could even get at the very core question that I started with, is certifications are there to make products more secure. But I mean, do they? So in theory, we could get as far as that, but that's years in the making. There's an obvious extension of the tool. I mentioned it multiple times in today's era. We can use LLMs to enhance the processing. So currently we have a private beta of being able to chat with your certificate or with the certificate of your competitors. The QR code will be repeated at the very end slide, so there will be ample time to scan it if you're interested. So what next? Seeing this talk, what are the actionables for you? Well, go at sectors.org and search for your own products, your company's products, or the products of your vendors, or even the products of your competition, and to see what they are doing and what they are certifying. Because now it's easy to find and easy to run stats, and you can then dive into individual certificates that are relevant for you. The project is fully open source and open data, which means that you can fork the repository with the library that allows you to browse and run stats on the data. It quite easily allows you to download the whole data set that is consolidated on our site from the certification website and perform deeper analytics. I mean, our software is free and open source, which means we run the same deficiencies as I've mentioned at the beginning for OpenSSL, which means please let us know that you are actually interested in that you are using it, and we will be happy to cooperate and happy to make a note that someone is finding it interesting and actually using it. Which gets me to the third point, get in touch. If you're interested in the research side of it, be it from the academic standpoint or from the industrial standpoint, or even from a public policy standpoint, if you are a company of sorts, if you are like a public body of sorts, or if you're willing to support the project or even help us push transparency in certifications, all discussion and negotiations are welcome. Because as I've mentioned, certifications are the world where we produce artifacts by people for people, so they are not necessarily machine processable, and there are incentives rather against making this particularly transparent, because the lab certification step is a commercial thing, so you pay to the lab to do the security assessment for you, and so they are not necessarily interested in having the work easily automated and easily seen in the statistical point of view to be able to compare the labs, because that would make a push on the competition, which they are not necessarily interested in. The public bodies and the certification authorities would kind of like the transparency, and there's an interesting change recently with the European Union certification scheme, the EUCC, which claims that there will be a centralized portal at ENISA, and everyone will have to send their certificates to them, and they will just publish structured information about all the certificates, and this really looks nice, and we are already trying to incorporate EUCC into sectors, although currently there's like 5 EUCC certificates, I believe, at the moment. So this is more of a proactive approach, so that when those certificates start pouring in because of the recent EU legislation, which we expect will cause many certificates, we'll already be ready. Which generally concludes the talk. We managed to save quite some time for questions. So to sum up, you can use sectors.org to get insights about products, components, configuration, the ecosystem, vendors, whatever you're interested in. Feel free to get in touch with either of us, or there are even many other people of the project at the conference. We'll happily involve you and collaborate if it makes any sense for either of us. With that, I thank you for the attention and open the space for questions.
I have a speculation that I want you either to confirm or deny. Given that FIPS 140 certifies crypto modules, Common Criteria certifies this and bunch of other stuff. I believe the numbers are like 6,500 certificates and 1,500 or no.
5,000.
Yeah. 5,000, yeah.
It's not that different in numbers.
20% or more. Yeah. About 20%, let's say. So given that the shares of OpenSSL in this case, in both ecosystems are about the same, this leads me to a speculation that even non-crypto products rely on crypto very heavily. Is that correct as a speculation or not?
Do you have any comments on that first? I can take it if you want.
Yeah, feel free.
Okay. That's a speculation, and I mean, we've all seen Barbies with mics sending all the data online, in which, and I'm not sure I would call the Barbie a security product, but I would actually want some cryptography and security in a Barbie. I'm not necessarily sure that, because it's true that common criteria are certifications for just about anything from a screwdriver to a coffee machine. And some of those have reasons to use cryptography, but plenty doesn't. It's a good. I don't think that they. I'm not sure where you base the idea that if you didn't need cryptography and you would be mentioning OpenSSL or other cryptographic materials, which is what I got is your statement, but. Just forgot what I wanted to say. It's an interesting thing to dive into, and we could run that as the analysis, but we would need to find a discriminator saying whether a particular product is a security relevant product or not. I'll happily talk to you.
It will be very likely security relevant.
Yeah.
However, what I'm trying to point out that there is a significant proportion, let's say 20%, of common criteria products that are not crypto modules. They are other security products. And still, they are using crypto as extensively as the crypto products. That's my speculation at the moment. And for us in academia, this is very interesting observation actually, because we are telling the students crypto is important, but there is a load of other stuff other than crypto in security. But this observation or conclusion that I'm making from your observations shows me that crypto is used heavily even in the non-crypto products. That's all I wanted to say. We can discuss that later.
Yeah, I would probably disagree that we know that it's even in the non-crypto products, because I'm very hesitant to declare which products are non-crypto. But it's true that OpenSSL is present almost across all the product categories and types available. Although we didn't mention that explicitly, but in some cases, it's not used even though crypto is relevant. For example, for the smart cards and integrated circuits, they definitely do provide with crypto primitives and cryptographic functionalities, but OpenSSL is just not the tool that would be small and easily embeddable because it doesn't aim at this audience, at that target space. There are different libraries that are most likely to be used in embedded devices. Yeah.
Maybe I have just one thought about it.
Yeah.
Yeah, like maybe because those are only certified products, yeah? And if you are talking about the coffee machines and stuff, which are not pretty much related to the cryptography, they probably don't need the certification. Yeah? So maybe they are not even included in there.
Yeah. Another question?
Good. Thank you very much for the talk. It's good that the graphs are available because it was too fast at that part.
Sorry.
But you mentioned that maybe you can answer the question if the security certification actually improves the security based on how you are measuring it, being it a number of vulnerabilities, seriousness, and so on. So do you think that you can also measure and try to evaluate if usage of specific libraries like OpenSSL results in products with less problems overall and better security? Does it make sense to do so?
Like, I don't know how to measure the amount of problems in the data set. So maybe there is an issue, like, but could be interesting.
Like one option is to use CVEs and
like
severity
those problems,
and stuff like that, right?
Though that one is tricky because there are certified products and modules that you could devise information about. As an example that I know from our own company, if you take the Red Hat Enterprise Linux RHEL, it has publicly available dependency information, so you see that it actually uses OpenSSL in a particular version, and you can say that the particular version is vulnerable, so particular RHEL has a CVE valid for it, and if the particular RHEL is certified, then there's a CVE, and you can say that, oh, it's a security-wise problematic product. However, the FIPS version of RHEL is a specific build that disables some of the packages, disables some of the configuration, automatically applies some of the hardening parts, and that is far from trivial to see from the public analysis of the dependencies. So some of the dependencies that cause the CVEs may not, and we have actually found the case when we were analyzing how much the CVE binding is reliable, we found that the CVEs was not relevant because the part that contained the CVE was not even included in the certified build. So yes, interesting direction. I would generally very much like if we were able to do this sort of analytics, but I'm kind of cautious with saying the results of this sort unless I'm reasonably certain that the results are correct, because it potentially goes into the direction of blaming labs for being slow or imprecise, or libraries to cause less secure products compared to other libraries. And I mean, I'm okay saying that if we have objective data to base it on, but I'm very hesitant to be saying these sorts of negative quotes if the data is not bulletproof, because it's just the way to hell. Academically speaking, if it was a research paper, you're much more free in that space than me saying that from any sort of a company perspective.
Thank you very much.
Any other questions?
I have one. So actually, it's had one on the CV topic. So one thing that I found is that this CV information is not very reliable, or there's actually two things, and that this certification, both in FIPS and Common Criteria, kind of makes companies stay with older versions, the certified version, which, as you said, is 1.5 years after submission.
Unfortunately.
Where there are, of course, known CVs after 1.5 years in the field. Maybe this research could kind of help users of certified products to upgrade more, because they get more awareness of the, say, the need for updating even certified products, because there's a real long lag in certification.
Generally speaking, you're completely right. A lot of the places where certified products are used either because they believe it increases certifications, or worse, because they are regulated to use certified products only, for example, the US government infamously, all the technicians there stand in front of a very bad decision that either they will be legally compliant, which means they will run the certified version, which is 1.5 years old by that time, or they are more secure, or most likely secure, because they run all the patched up-to-date versions, but they are legally incompliant, which is a very bad decision in some places. As you mentioned, the research of this sort could lead people to update more and patch more and use newer software if we've shown that certified products are correlated with CVEs and have them. Though on the flip side, I would claim that this was basically claimed that certifications are security-wise useless, which maybe is the case, maybe not. It's very difficult to judge. But I would very much like to use the research on the flip side to push the certification community to show that if you want certifications to actually make sense and make things secure, we need to get rid and resolve some things. For example, waiting for 1.5 years to get your certification approved. So hopefully this sort of data, because certifications are slow, that's the no shit Sherlock slide that I had on OpenSSL. Everyone knows that, but we don't really have data, or very barely, so pushing anyone with the gut feeling is much more difficult than pushing them with the actual data if you were able to show that, oh, because you were so slow, there's so and so many CVs and so and so many products in so and so many certifications which are now kind of useless, or actually forcing people to use insecure certified software. So that is a better direction that I would want, rather than convincing the users to use fresh software instead of certified software. A question over there?
more remark from the practical side of certification. So even if you start the certification with an older version of a library, at the end of the process you have to do some sort like avant. So I don't know the long term in English right now. So you have to analyze all your flaws. And if during the long certification process CVE against a library you use occurs, you have to analyze it. And only if there is a CVE which does not affect your security, then you can keep the old version. Otherwise, you have to update the version, and that's okay during the certification. Of course, unless you have to use a certified version of the library, which almost, at least for us, is not the case. So even if you have CVEs, for a certified product, you can be sure that they are analyzed and not relevant for the product.
Mm-hmm. Generally speaking, the situation in this respect differs a bit in between different certification schemes. For example, for FedRAMP, there's a requirement that by the moment that you submit your certification proposal, there has to be no known vulnerability on the particular product. So if there's a public CVE announcement 3 days before you have a product submission deadline, you're screwed, because you would need to incorporate that in 3 days or move the deadline, which is a real-world scenario that we've been over and probably you've been over as well. And as you mentioned, in some cases, CVEs during the certification process need to be analyzed. A further improvement that we hopefully could somehow push in the whole certification ecosystem is easier recertifications or certification updates, because it's either we make it faster and certify it more often, or when there's a CVE, we patch the product and do a very quick recertification of like, we've updated it or this or fixed that, so that now there's a patched certified product kind of close after the patch release and the CVE release. So that's also a thing that is very difficult now and could be easier.
So that. I think we don't have time for more questions, so we'll have to, approach Martin and Vladimir after the session and discuss more. There's tons of interesting discussions on this topic. I enjoyed the presentation very much. A round of applause.